Thank you for that very kind introduction. I'm very honoured to be your guest here. It's my first visit to mainland China, and it's been a great visit so far, and I expect it to continue that way until you give me really difficult questions I can't answer. And it's a very honour to be part of the anniversary celebrations and to be giving the Yan Fu lecture. Well, I think it's entirely appropriate because, as you are certainly aware, Yan Fu studied in Britain and promoted intellectual engagement between China and Britain and China and Western ideas generally in both directions, and was particularly interested in science, and that's the area I'm interested in. So. Yeah, I feel it's appropriate, and I'm very honoured to be doing this. Okay, so that's not the slide I want to be having. Okay, so so what am I going to be doing? That's what I was supposed to have included on the previous slide. I'm going to be talking about knowledge first epistemology, this new development in epistemology that clearly some of you, many of you, if you're interested in epistemology, will be aware of. And I'm interested in what significance this new area of epistemology, or newish, has for the philosophy of science. Because it's clear that knowledge first approaches a significant departure, significant innovation for epistemology, but it hasn't been much discussed that it has significant consequences for philosophy of science. Indeed, some philosophers of science, you doubt that developments in what we would call core epistemology, central areas of epistemology, have any significance for philosophy of science. So Philip Kitcher, famous philosopher of science, Columbia University in New York, but British, he says philosophers of science don't care about these debates in epistemology, internalism versus externalism and so forth. They have no significance for philosophy of science. Well, I think that's a mistake. I think that's wrong, or at least as far as this is concerned. So that's my task, is to show that knowledge first has some relevance for philosophy of science. In fact, very great relevance. Okay, so traditional epistemology might be thought to be belief-centered. That's the mental state that we're interested in, and we're interested in asking questions such as, when is your belief justified? When is it that the belief gets to be knowledge? And therefore we ask, we think that other epistemic conditions might be analysed in terms of belief. So knowledge, we think of, we have a project, where there has been a project of trying to analyse knowledge as belief, true belief, and some other condition, like justified true belief. No, that doesn't work. Get EA. Try something else, and so on and so forth. But it starts off with belief and then builds up from belief to other things. Whereas the knowledge first epistemology, due to Tim Williamson, and this got going really about 25 years ago. His famous book, Knowledge and Its Limits, was published in 2000, but that was amalgamation of some work that was going on over the previous few years, when I was fortunate enough to be a colleague of Tim Williamson's at Edinburgh University. And this approach is not belief-centered, but is knowledge-centered. It says that, well, its questions are, how do other epistemic conditions relate to knowledge? Not to belief, but to knowledge. So your knowledge first epistemology will say things like that the state of belief aims at being knowledge. That when you believe something, there's a sense in which the success conditions on believing that it achieves the state of knowledge. Knowledge itself is a genuine mental state. It's not made up of belief plus other things. It's a mental state in and of its own kind. Mere belief that fails to be knowledge is a bad kind of belief. It's, we say, botched belief. It's belief that fails to be what it should be. So I said, your knowledge is a mental state. It's the most general factive mental state. That's to say, seeing that, remembering that. These are factive mental states, and they imply knowing. And the most important from today's point of view is the claim that what evidence is knowledge. Okay, that's just a very quick introduction to knowledge first epistemology. We don't really need to spend much time thinking about it, other than just to give you a little background, where this is coming from. We're starting with the idea that knowledge is important. Okay, so let's now turn a little bit to philosophy of science. So what are the key questions in philosophy of science, or epistemological philosophy of science? Well, possibly a key question is this confirmation question. When is it that some piece of evidence confirms a theory or hypothesis? That is one of the central questions of epistemological philosophy of science, the question of confirmation. What is confirmation? When is it that some evidence favors a theory or disfavors a theory? And so this is a relationship between an evidence proposition or set of evidence propositions and a hypothesis. And answers, there are lots of answers in philosophy of science. You might be familiar with hypothetico-deductivism. It says E confirms H when you can deduce E from H, or E from H plus other known conditions. Other people will favor Bayesian confirmation theory. There are other theories of probability that might be put towards your theory of confirmation. But we have this, the theory of confirmation is all about trying to answer this question, to say what exactly is the relationship between E and H for E to confirm H. Okay. So that's the confirmation question. But if you're looking at some particular piece of science, there's a slightly different question that you might be interested in, is this theory, is this hypothesis in fact supported by the evidence that we have? So a slightly different question, because this is in some senses asking a slightly conditional question, which is, if you have evidence E, would it support H? This question is asking, does our actual evidence support this theory? To answer this question rather depends on what your evidence is. I mean, this question is independent of what your evidence is. It says, if your evidence is E, does it support H? But this question says, is your theory supported? In which case you have to know, or have an idea of what your evidence is. So we need to ask, so this introduces an additional question, which is, what is your evidence? Right? So in a sense, this involves two questions. What is the evidence, or what is the evidence that we have, and does that evidence confirm H? So the confirmation question concerns the second half of this. But to know which theories in science are well confirmed, we have to answer this question: what is the evidence? Okay. So that's just repeating what I've said. So it's this question, the confirmation question, that has gotten all the attention in philosophy of science. But what I hope I've just shown is that we need to give this question some attention as well. But it's not been given the attention that it deserves. But it's important to answer it well, because assuming a sensible answer over here, assuming a sensible answer to the confirmation question, if you answer this wrongly, then that has bad consequences. Because if say I have a theory of evidence that's too inclusive, well, then it might make it easy to confirm hypotheses. So, for example, if I said, our evidence, or someone's evidence is just what they believe. If to be evidence it's sufficient to be a belief, well, it's easy to confirm theories in that case. I just believe stuff, right? And then, and as long as I find myself believing lots of things, then it's easy to confirm a theory. If, on the other hand, our theory of evidence is too restrictive, too exclusive, we go the other way. We might find that very few theories are, in fact, confirmed. So, for example, if you think, to be evidence is to be known with absolute certainty, then you might find that, very few theories are, in fact, confirmed because we don't have much evidence or any evidence by that standard. So we need to get this question right in order to have a good answer to the question, which theories in science are well confirmed? Is this theory well confirmed by the evidence? Well, we need to get this question right. Oh, sorry, I touched it. That's a bad idea. So a crucial question is, what is evidence? What is the evidence that we have? So the knowledge first theory, approach to epistemology, knowledge first has a clear answer to this, or at least Tim Williamson has a clear answer to this, which is a proposition is in someone's evidence exactly when they know that proposition. Evidence is knowledge. Nice and simple. Okay. I'm not going to spend, I'll spend a little time explaining why this is a plausible view. I mean, Tim Williamson, in his book and in his papers, has some arguments for this. I think they're good arguments. But here's a couple of reasons why I think this is right that are independent of Williamson's arguments. First of all, we say we were scientists, or we might be not scientists, we might be, I don't know, a team of police detectives. Right? We're investigating some question. We've got a hypothesis or a theory, a scientific theory, or a theory about who the criminal is, or something like this. And we ask ourselves, is this theory supported by the evidence? Say we wanted to ask a question that did the same job, but without using the term evidence. And I know this is slightly linguistic, so it's interesting to know whether this makes sense translated into Chinese or not. But yeah, certainly in English, if you couldn't use the word evidence, what question might you be asking? What's an alternative question that would do the same job? Well, you might easily find yourself in the same situation. Got this theory, we want to know whether it's a good theory or a bad theory. We might say, instead of, is this theory supported by evidence, we just say, is this theory supported by what we know? Right. Or alternatively, you might say, you're investigating something, you say, what is our evidence? But you might equally say, what do we know about this person? What do we know about this crime? Seem to be asking very much the same question as, what evidence do we have about this person? What evidence do we have regarding this crime? Other options just seem to be, certainly in English, seem to be weird. Right? You could ask, is this theory supported by what we believe? Okay, you could ask that, but it seems a different kind of question. Or is it supported by what we believe with certainty? Or is it supported by what we believe with justification? You could ask those questions, but they seem a little bit artificial, and they don't seem to be asking quite the same question, whereas the first two seem to be more or less interchangeable, at least in English. Okay, so there's a little bit of data in favor of that. Here's a different thing. If you're starting from a knowledge-first point of view, one of the things you think is that, as I mentioned earlier, is that belief aims at knowledge. That's to say that the criteria for successful believing is that it should amount to knowledge. So we all have beliefs. And it turns out that some of our beliefs are false. Even I have false beliefs. Especially I have false beliefs, I don't know. But yeah, insofar as one of my beliefs is false, that's not a good thing about that belief. It's failed to be what it ought to be. But I might have a true belief, but it's true by accident. Yeah, I only believe it because of wishful thinking. Yeah, I believe that Arsenal will win the Premier League in England, right? It's looking a bit dicey, isn't it? I believe that they will, but it's only because I am a great supporter of the team. It might turn out that belief is true, but you might think that that was slightly lucky that it came out to be true. Yeah, it wasn't justified, perhaps. Yeah, Manchester City are ahead at the moment, and they So yeah, again, it doesn't seem to be as entirely satisfactory belief, even if it's true, if it's not justified, if it's wishful thinking. So the knowledge first claim is the conditions under which a belief is fully satisfactory are that it amounts to knowledge, it succeeds in being knowledge. So presumably that means that when we make inferences in science, to conclusions in science, then perhaps these scientific inferences should aim at knowledge. But just as we were saying a moment ago, how do we get to a conclusion in science? Well, science is a matter typically of reasoning, making inferences. So there's two components to getting to a conclusion in science. There's the inference procedure that we make, and there's the evidence upon which it is based. And if we're doing science well, then those together should lead to knowledge. Okay, that's the... Yeah. I mean, if you're not a knowledge firster, you won't necessarily believe all that, but I'm saying this from a knowledge first perspective, this is what you would expect or you want from science. You want the combination of your evidence and your inference procedure to lead to knowledge. So here's the question. Does this aim of achieving knowledge in science from our evidence plus the inference, does this put conditions on what evidence can be? Well, clearly it does, right? Because if I allow something to be evidence that is false, say if I say, anything is evidence if I believe it, right? Well, that's not going to lead to knowledge, right? Because some of my beliefs are false. And even if I use a really good inference, my logic is perfect, starting off with a false belief won't lead to knowledge. Even if it can lead to truth, but it can't lead to knowledge. So one way of looking at this is to say, let's assume that we're using perfect logic, perfect reasoning. What must evidence be like such that it leads to knowledge? Well, there's a long argument in my book, but I think you can see that it's plausible to say the conclusion of some reasoning will be knowledge when you've got a good inference procedure and your evidence is knowledge as well. Right. If your evidence is less than knowledge, because it's false or it's not justified, then it will fail to, what you end up with will fail to be knowledge as well. So the conditions for evidence leading to knowledge will be that the evidence is itself knowledge. Not the same knowledge, obviously, but has the status of knowledge. Okay, so this is what I call a knowledge-first functionalist conception of knowledge. That's a mistake. This is a knowledge-first functionalist conception of evidence. Right, okay. Evidence, this is it. Evidence is that which leads to knowledge when used as the premises of a faultless inference procedure. That's the sort of summary. But I think you see what I'm trying to say is that evidence is got to be of a certain quality if it's going to lead to knowledge, and that quality just is knowledge itself. Okay, so we conclude that evidence is knowledge. Okay, and we'll see in a moment why that's important. I want to talk a little bit about empiricism now. Empiricism is I'm a big enemy of empiricism. Let me get that on the table. I'm not an empiricist. And the slogan for my recent book that you kindly mentioned, Knowing Science, is empiricism, with knowledge good, empiricism bad. And you might think that's a very strange thing for a philosopher of science to say. You might think that empiricism is sort of like the official philosophy of science. But I think that's a mistake. So what do I mean by empiricism in epistemology or epistemological philosophy of science? It's any epistemology that gives a central role to perception. That's the important bit. It's perceptual use of our perceptual capacities that makes. If you think that's really important for epistemology, then you're some kind of empiricist. So here are some things that some philosophers of science have said that show that they are empiricists. So Patrick Maher says he has an empiricist conception of evidence. A proposition is in some subject's evidence if and only if they know that proposition directly by experience. And he means sense experience there. So for Patrick Maher, inferred propositions, and if you've inferred it, you come to know it by inference, it's not evidence. Right? You've got to know it directly by experience. Okay. Here's Hasok Chang. Observation is an act of gathering information by human sensation without optional interpretations. So when he says human sensation, again, he means sense perception. So this is an empiricist account of observation. And because he's talking in terms of philosophy of science, observation is, for him, key to scientific knowledge. Very much in the same vein, Anjan Chakravarti says, there are things that one can, under favorable circumstances, perceive with one's unaided senses. Let us call them observables. Again, an empiricist account of observation or observable. So these are all empiricists. So I'm going to use, thinking about the second and third of these, Chang and Chakravarti, I'm going to use observable with this subscript P, observable P, to mean observable as these guys think of it, meaning something to do. Observable for them is you can see it, you can perceive it directly. That's the standard way in which the term observable is used by philosophers of science. Philosophers of science are by default empiricists. So they think observation is a matter of perception. What Chang and Chakravarti say there is just like standard for many philosophers of science. Most, I think, almost all. So here's an argument that is familiar in philosophy of science in one form or another. First of all, first premise is, look, the evidence of science is a matter of observation. We get our evidence in science from observation, where we understand observation in this empiricist way with a P for perception. Okay. Second premise, the conclusions of science often concern, or the conclusions of theoretical science anyway, concern unobservable stuff. You know, the science seems to be telling us about the internal structure of atoms, or about the age of the universe, or things that are going on at the edge of the universe, or they tell us about magnetic fields, gravitational waves, right? Science tells us about, or at least has theories, conclusions concerning all these things that are not observable, certainly not observable in this perceptual empiricist way. Here's the third premise of this conclusion. You can't reasonably draw a conclusion about the unobservable from premises concerning only the observable. If all I know concerns the observable, I can't reasonably draw a conclusion about the unobservable. Now put these three together, and then you get these two conclusions. You can't have a reasonable belief in the relevant conclusions of science. I can't have a reasonable belief about gravitational waves, because all my evidence is observable, and I can't make a reasonable inference from the observable to the unobservable, but gravitational waves and all these other things are unobservable, so I can't have a reasonable belief concerning those things. And therefore, those propositions can't be part of my knowledge. If I do believe them, I can't know them to be true. So this is an anti-realist conclusion. And it's what I call the pessimistic deduction. You've probably heard of the pessimistic induction or the pessimistic meta-induction. Well, this is what I call the pessimistic deduction, because it ends up with this anti-realist conclusion, and it's a deductive argument. Now, yeah, and something like this is, I think, implicit in a lot of anti-realist philosophy of science, even if it's not explicitly put down like this. So it's very difficult to for instance, pin this on Van Fraassen. But I think it's something like this must be motivating Van Fraassen. That's why he would say, well, in fact, the conclusions of science don't really concern the unobservable. We accept our theories, but we don't believe them. Yeah? So I think there's a lot that you can find some arguments related to this, or motivations related to this throughout philosophy of science, at least throughout anti-realist philosophy of science. So, of course, not all philosophers of science are anti-realists. So the question is, if you are a realist philosopher of science, which of these premises do you reject? Right? Anyway, first of all, to point out that this premise here is what makes this an empiricist argument. But it's not that premise that the realists have a problem with. The realists typically argue about premise number 3. So the scientific realists will say, oh,
these are the ones who are not pessimistic, they're optimists. The optimistic empiricists will say, no, this is false, because inference to the best explanation is the way that we can get from premises concerning the observable to conclusions concerning the unobservable. It's because the existence of atoms and molecules best explains Brownian motion. We can observe Brownian motion, but we can't observe the atoms, but they best explain the Brownian motion. So they will reject premise 3. But my point is that these are optimistic empiricists because they nonetheless accept this premise. It's that third one they reject. They accept this premise. But I think that that's a mistake. Because what does this premise say? The evidence of science concerns only what is observable. But let's assume from the previous section that we agree that evidence is knowledge. These are the same thing. Then what is this premise really saying? Well, it's equivalent to, not when we say the evidence of science, we can replace evidence by knowledge. And we say knowledge in science concerns only what is observable. Right? So, yeah. But that there is pretty much the same thing as the conclusion of the pessimistic argument, that the conclusions in science can't be knowledge. These are pretty much equivalent. Knowledge in science concerns only what is observable, but the conclusions of science, insofar as they concern the unobservable, aren't knowledge. So what I'm saying is that if you accept premise 1 and you accept E equals K, then you've already got the conclusion, right? You don't have to go through the pessimistic deduction. You don't have to go through the stuff about what you can infer from what. So it seems to me that the empiricist, this empiricist argument, it looks like an empiricist argument for anti-realism, but in fact, its very first premise begs the question. By saying that our evidence is limited to the observable, we are already accepting that we can't know anything science other than the observable. But that's just the conclusion of this pessimistic argument. So I think it's question begging. So what's this slide saying? So that's the pessimistic. I wanted to say something more about this premise, not simply that I think it's question begging and that we should reject it, but I also want to point out that it's not consistent with what scientists themselves say. Right. So scientists do not use the term evidence in a way that limits themselves to the observable, however you construe the observable. Look at this. So here we go. This is a really important paper in fundamental physics. The Atlas collaboration is international collaboration, includes colleagues from all over the world, including China, I think, at CERN with the Large Hadron Collider. Right, so this is paper, evidence for the spin zero nature of the Higgs boson using Atlas data. So what's the evidence they're talking about there? Turns out that you look into the paper, the evidence that they're referring to is the fact that the Higgs particle, this Higgs boson thing that was discovered in 2012, that it decays into photons and into Z bosons. So it looks at decay patterns of and that's the evidence for the spin zero nature of the Higgs particle. At least according to this scientific paper. So these scientists, what they call evidence, like the decay of a fundamental particle, is stuff that's way not observable, right? Way non-perceptual, rather. Non-perceptual. I won't say non-observable. So it's non-perceptual, right? So they do not use the term evidence in a way that limits itself to the perceptual. Here's some other things that we see. Theoretical evidence for the sensitivity of charge rearrangement in a paper by Howe and colleagues. Theoretical evidence for, look at these titles, right? These titles are inconsistent with the idea that evidence is always observational and with the idea that evidence is always perceptual. Okay. So evidence can be theoretical, it can be highly non-perceptual, okay, as far as scientists are concerned. Now, normal philosophers of science, empiricist philosophers of science, you're committed to saying, oh, well, scientists, they're not philosophers, they don't really understand, they shouldn't be used, properly speaking, they shouldn't be using the words evidence and observation in these ways. I think they're using in perfectly good ways, in the ways that they ought to be using them. Okay. So I think, here's some more. That was talking about the use of the term evidence, but here's the term observation. I'm sure I had some other papers listed. But anyway, you can find also in the literature, lots of use of the terms observation, where what is being observed is highly non-perceptual. I messed up. Also supposed to be on here are things like the observation of gravitational waves using the LIGO apparatus and so forth. Again, gravitational waves are not things you can perceive, but scientists make observation of them. Okay. Right, so that's the first sort of chunk of the talk. I'm going to have to speed up a little bit. I want to talk about another highly influential idea in philosophy of science, and that's the Duhem Quine thesis. So according to Pierre Duhem, scientific theories are not refuted singly, but only in sets of multiple hypotheses together. So here's the idea. Hypothetical deductivism tells us that if a theory or hypothesis entails some observation, and then you make the observation and you find that you don't get what you predicted, then your theory must be false. Your theory is refuted. Popper type idea. But what Duhem is saying is, in fact, you will find that you don't get a nice simple situation like on the previous slide, because actually, in order to make a prediction of an observation, you typically have to have we always have to have multiple hypotheses together. And that means that if what you predicted fails to be observed, then you know that the conjunction of these multiple hypotheses is false. But that doesn't tell you which individual one of those hypotheses is false. So you've refuted their combination, but not any one of them individually. So we're sort of testing the combination, not individual hypotheses. So here's an famous example. Newtonian celestial mechanics gave us tells us what the orbit of the planet Uranus should be, but when observations of the planet Uranus were made, it was found to be anomalous. So you might, but we couldn't conclude that Newton's theory of gravitation was wrong, because in order to make the prediction of what you should observe through your telescope, you need not just Newton's theory of gravitation, but lots of supplementary data about which all the planets are and what their trajectories are and so forth. This is only part of what you need. But amongst the assumptions that you're making are that these are the planets. Only these are the planets. So it's a simplified version. So we know that this combination is false, but we don't know that it's which of these it is. It was hypothesized that it was this one, and there's an unobserved planet, and then we discover that's the one that's wrong, and that leads to the discovery of Neptune. But when the same situation arose a couple of centuries later with respect to the orbit of Mercury, we made a different choice, as it were. We decided, oh no, it's Newton that's wrong this time. And people did wonder whether this might be wrong. Oh, there's this planet called Vulcan, we can't see it because it's so close to the sun. But there in the end up, we ended up rejecting Newton and replacing him by Einstein's theory of relativity. Okay, so you can see that that's how the Duhem problem arises. Quine adds to this by saying it's not really, when you really think about it, it's not just small finite sets of hypotheses that are tested together, but it's the whole web of belief that is really ultimately up for test. Because in fact, we need lots more information than these assumptions. We need, for example, mathematical assumptions to derive predictions about the orbit of Uranus. I mean, if you really wanted to, you could consider the possibility we should change our mathematics. Right. And in fact, if you think that what the prediction is not a fact about Uranus, but a fact about our perception of Uranus through the telescope, then there are many more assumptions that you make. You have to make assumptions about light, assumptions about the telescope, and so on and so forth. Of course, this assumption that what we're predicting is a perceptual thing is, of course, empiricism again. And we've just seen how bad that was, right? Okay. But that's not really what I'm focusing on right now. I'm just focusing on this idea that when we're in this situation that we've used a bunch of hypotheses together to make a prediction, and the prediction fails, that there are lots, we know that the combination is false, but as a which one, there's a question, which one should be rejected? And the question is, how do we choose which one to reject? And there are various answers to this. Duhem himself says it's a matter of the good sense of the scientist. The scientist uses her good sense, his good sense to, it makes most sense, It's a matter of acquiring certain scientific skill that you choose the right one to reject. Quine has this principle, is maxim of minimum mutilation. So you just think about your overall set of beliefs. If you, for example, if I were to say, oh, well, I think I will reject the mathematics that I used, then that might be a bit problematic, because if you suddenly think, well, I'm not sure that 2 + 2 does always equal 4 rather. Sometimes equals 5, possibly, right, or something like that. Then that's going to mess up all your other beliefs for which you've used 2 + 2 = 4. So that would mutilate your set of beliefs a lot if you were to change that one. So you mustn't do that. So he has this maxim. And in fact, there's quite a lot of theory about how to make this choice. So there's the AGM theory of belief revision and theory choice. And there's a similar idea to Quine's maxim of minimum mutilation going on there. So there are various theories about choosing which one to reject. But if you're a knowledge-first theorist, this whole thing just dissolves away, right, as a problem. Because if you are in this situation, that you know 3 of your hypotheses are true, then it's clear which one you reject. You reject the one that you don't know to be true. Simple, right? No problem, no contest. If you allow yourself the idea that we can know some stuff in science, then you might be able to say this. So why do I think this is a sensible, a genuine possibility? Well, first of all, the justification for this approach is this. Look, we have these kinds of principle. Reject any hypothesis inconsistent with what you know, or reject any hypothesis inconsistent with your evidence. These seem to be good principles of epistemology, or good principles of science, indeed. We can use the principle of closure. What am I saying? Right, okay. Yeah, so if I make the observation, and I know that these 3 hypotheses are true, if these are all known, then if I deduce that H is false, H1 is false, then that will be knowledge, because I'm deducing a conclusion from known premises it's a competent deduction. My point here is that there are many ways of justifying this slide. So the relevant objection to this slide might be, or can only be, well, possibly are we ever in this situation? Right? You might think, oh no, well, it's all very well if we are in this situation, but are we ever in this situation? But to deny the possibility of being in this situation is to deny the possibility that we can know hypotheses in science. So to deny the possibility that we're in this situation is to start off by being a skeptic about science, by being some kind of anti-realist. If you're a realist about science and you think that we can know some hypotheses to be true, then you might think we can be in this situation. But the question is, let's say you are faced with that position. Go back. You're faced with this situation. How, in fact, do we choose which one? And you might say, well, we'll choose to reject the one we don't know. But that seems to require you know which ones you do know. Right? And then the question is, do I know which ones I know? After all, one of the lessons, well, one of the features of knowledge-first epistemology is that you can know something without knowing that you know it, right? So you might be in this position, but still not know that you are. Not know that these are the ones you know, and that's the one you don't know. Well, look, one thing to say is it may be a demand of rationality that you reject H1. That's the conclusion I want to. That's the important conclusion that there is a correct answer as to which one you should reject. It's H1. That's the one you should reject. And you might say, well, hang on, I don't know which of these I know. Right, so look, sometimes what it is rational for us to do isn't always perfectly luminous. What do I mean by that? It's not always perfect. It's not, the following is not the case. It's not the case that if it's rational to do this, I must be aware and know that that's what it's rational to do. There can be some things that it's rational for me to do, and I'm regrettably ignorant of what rationality requires me to do. So it's not an objection that I don't know. I mean, it's unfortunate, but it's not an objection. We have to distinguish the following. To apply, for a belief to be rational, you must know that you're applying the rule correctly. And the following thing. For a belief to be rational, you must apply the rule in a certain way because that's the correct way to apply the rule. So it might be that you are being rational because you're following the correct rule. But it doesn't mean that you must therefore know that you're applying the rule correctly. I mean, this is possibly a matter of detail that we can come to in the questions. But I mean, I think that there are important things that we need to distinguish here. Yeah, look, the fact that perhaps this is the more important point. The fact that it's possible to be in a situation of knowing H2, H3, and H4, but not knowing that I know them, that's right. We can be in that situation. Doesn't mean that we must be in that situation. Yeah. Just because you can know without knowing that you know doesn't mean you can't know and know that you know. And I think that we often are in this position of not only knowing which H1, not only that we know H2 and we know H3 and know H4, but we also know that we know those things. So we can be in the position of knowing exactly what the right thing to do is. And a good scientist will choose her auxiliary hypotheses precisely to make that the case. Right. So when you are designing an experiment to test some hypothesis, you will design your experiment using assumptions that you are able to justify and to test rigorously. And because you've designed your experiment to depend upon things that you're absolutely reliable know and have tested, you do know that these auxiliary hypotheses are not only true, but you know that you know them. And I think that's right. I think you design an experiment. And it assumes that there is oxygen in the atmosphere. That's not only something that we know, that there's oxygen in the atmosphere, but we know that we know it, right? We can talk about why we're justified in thinking that. Yeah, we're in a position to know that we know it. Okay, so the conclusion is, of this bit, that hypotheses can be tested singly. We can make rational choices about which hypotheses to reject. And that one can come to know that a hypothesis is refuted by a test. So it's not really the case that we, in a sense, have to test hypotheses only as a bunch, let alone the whole web of belief. But we can indeed test hypotheses singly because there's asymmetry between them. Yeah. The hypotheses, in some sense, that we're using are implicit in our experiment, in a good experiment, are such that we know some of the hypotheses to be true, and there's only one that we don't know to be true. And so when the experiment gives us an observation that is against prediction, we know which one to blame. Okay. Very last slide, I think. And it's just going back to the earlier section, give a little bit of a picture about what's going on in science in relation to evidence and knowledge. So earlier on, I had this little way of thinking about things that science involves reasoning from evidence, so there's inference procedure or reasoning procedure, and there's evidence, and together they lead to knowledge. But let's forget about the inference for the moment. What we're interested in is the evidence-knowledge relation. So we use our evidence, we make an inference, and we add knowledge. We get some new knowledge as a result of this. But of course, we said that knowledge is evidence, so this knowledge is also evidence. Right? And but it's now it's added to our stock of evidence, and that can be used to generate new knowledge. And that knowledge is evidence, and that can be used to generate new knowledge, and so on. And in this process, we are getting often more and more theoretical in the sense of getting more and more away from ordinary everyday experience, further and further away from what is perceptible, and so forth. But once it becomes knowledge, it becomes evidence. That's why scientists were happy to say, oh, amongst my evidence for this theory is the fact that the boson decays in this way. You think that's highly theoretical evidence, in the sense of it's at a high level of theory, but it's knowledge, it's evidence because it's been established well enough to be knowledge. So that's why the scientists are happy to talk in this way. I'm not saying that all our evidence comes from inference. Clearly not. Not all our evidence does come from inference, but some of it does. There's non-inferred evidence as well. New knowledge might require that, and this will be stuff like data from experiments. Although I should, at this point, be quick to say that the data from experiments, in my view, is not typically these days, or it doesn't have to be, perceptual stuff. This is not where perception comes in. Because, for example, the new data collected by the Large Hadron Collider, the ATLAS experiments, that's all collected automatically by highly sophisticated bits of machinery. It's not like the old cloud chamber experiments where a scientist takes a photograph and she or he gets a ruler out and measures stuff on the photograph, where there's a perceptual engagement with something, even if it's only a photograph. The particles, decays, that all happens in these calorimeters and stuff, and it's all highly automated. A scientist working at CERN, if she or he sees anything at all, it's a computer screen. Right? And it's a computer screen in which data, highly processed data, is given to them. But it'd be crazy to say, oh, yes, empiricism is confirmed by the fact that scientists look at computers. Right? There's perceptual engagement with a computer screen and an Excel spreadsheet or whatever. That's crazy. So non-inferred evidence itself is not perceptual typically in modern science. It can be in some, but anyway. So that's the end of that. Okay, thanks very much. Thank you.